Jesse, welcome to Stories in AI. It's an amazing pleasure to have you today. How are you?
I'm doing great, Ganesh. Thanks for having me.
Thanks for jumping on. And why don't you kick us off with your story, your background, how your journey into being the chief data scientist at Q2E Holdings and Q2 Banking. Uh, Over to you.
Okay, great. Um, been at Q2 for about 14 years now. My background prior to Q2 was in mathematics and pizza delivery. So I was in grad school at the time.
I did not know that pizza delivery and mathematics. What a great combination!
Yeah. I'm at UT Austin, kind of working,
Go
working
on.
through
Yeah.
mathematics, working on my PhD over there, and lo and behold, somehow ended up in a conversation with Adam Blue, CTO over here at Q2, and Hank Seal, the founder, and they were like, "Hey, can you use math to stop fraud?" And being naive and a person who knew mathematics and, like I said, pizza delivery, I'm like, "Oh yeah, sure, totally, we
Now,
can get that done."
well, quick
Yeah.
digression. Adam has, and you have this amazing story at Q2, and I've heard this. I've met other people, who came from really like super weird, non-traditional backgrounds to being in software engineering and data science and stuff too, right? So I want to call that. You Q2 has built an amazing business here in Austin, and it's such a rich pool of very, very diverse talent. When I remember like interacting with you guys when we were working together in my last company, and so I want to just call that out because you were delivering pizzas, and Adam and you had a conversation about, hey, what would it take to actually use mathematics to stop fraud? It's amazing. I only expect that from Adam.
Yeah, so that's my background. Dropped out of grad school, came on to Q2, and was going to use math to stop fraud. So there you go.
That is awesome. That is awesome. And then you grew through the ranks. You were in software engineering. You were building models, and then you evolved into now the chief data scientist at Q2, right? Um,
That's right. That's right. That's right. A lot of twists and turns there along the way, but it's been quite an interesting kind of sequence of interesting and difficult problems, all of all different kind of shapes.
yeah, yeah, no, totally get it. Why don't you give a little bit more detail on that, right? What kind of problems are you solving today? Where is Q2 in that journey with AI in general? Now, just to you know the background, but this show is we have a lot of listeners from peers of yours from the industry, from different industries as well, not just financial services, but also a lot of entrepreneurs and problem solvers and innovators who look at this and learn from folks like you. So yeah, give us like what does your day in the life look like, and what are your mandate at Q2, and what are the classes of problems that you're solving today with ML?
Great, great, great. Yeah, thanks. So I always tell people I spend my time, as much of it as possible, just at the intersection of the most important and pernicious and difficult problems that our customers and our end users have on the one hand, and our data assets on the
Yeah.
other. If I ever stray too far away from there, well, I know I've lost my path, and I need to get back. I need to get back on it. I like to build things. So my role is my role is the technical one. I write code. I build into to problems. Like I said, preferably hard ones, and oftentimes it's problems that just by their nature require access to data, mathematics, machine learning, and so on. So that's what I do.
Got it, got it. And so talk about the problems Q2 is solving with machine learning and AI in your space, in your industry.
So no surprise. Fraud jumps way up to the top of that list. Fraud is one of these problems that never ever gets easier. It only ever gets more difficult. We've got this very clear kind of adversarial relationship between people like myself and the engineers that I work with on the one hand, and then bad actors on the other.
Yeah.
They're highly incentivized to be good at what they do. They are good at what they do. Many of them incredibly technically adept. Got nothing but time. Probably not going to go to jail. So they're out there, doing what they do, and continually kind of evaluating the kind of the surface of that adversarial relationship, looking for holes to poke in it. So no surprise, that kind of that kind of problem area is it's a great great proving ground for mathematics, for machine learning, for kind of data science. So no surprise that we do a lot of machine learning engineering around that problem and related problems. In addition to that, we care a lot about behaviors. You can imagine being in the financial services industry. We have access to a very rich set of data that could potentially be mapped down onto behaviors. So thinking about kind of transactions, traversal events as individuals kind of interact with our systems across the wide world, and then they go and transact. Well, there's a very rich kind of set of data out there, and well, it turns out understanding individuals kind of through the lens of that data is a great way to learn about their problems. Right? If you can learn about a person's problems, well, you're much better suited to help them, to give them something that they need. Sometimes you give them something that they didn't even know they needed. And the way that we do that, the way that we generally engage in that practice is by again, just maintaining a keen and a really consistent eye towards the problems that our end users and that our customers have, and then going back and kind of backing into those problems from our fairly substantial data assets.
So a couple questions there, right? One is on the fraud domain itself, right? The age old problem is, anomaly detection. You're actually looking for anomaly to the way transactions are being made. But given how sophisticated, as you said, those bad actors have become, right? You're less likely to see a sore thumb sticking out in a time series data that says, haha, there's a problem anymore. You're going to likely see a lot of this gradual evolution or patterns that are like kind of hidden, but not really hidden, that you have to look over a temporal period of time to actually go solve it, right? Ty, can you dive as much deeper as you can go into that in terms of like, just give us a flavor for some examples of the kind of fraud that you're able to detect, right? And using machine learning.
Well, it's interesting, the fraud that we see is across a fairly wide spectrum. And you look at it on the one end, and kind of these more commercial facing attacks that are focused on larger accounts, more prominent kind of companies and individuals that bad actors will go after. Why? Well, because they know that the asset sizes there are larger, there are larger balances, and so on and so forth. So you look at those attacks, and there are a couple of kind of hallmarks that come along with them. They're extraordinarily sophisticated, just in terms of their technical depth.
Yeah.
They're very targeted towards individuals. And of course, the dollar amounts that they're after are often very, very large, hundreds of thousands, going on into the millions of dollars. But again, the kind of character of that attack is very firmly situated at that end of the spectrum. If you kind of traverse that spectrum onto the retail end, it looks much different. You still there's less of a reliance on technical acumen by the bad actors, technical sophistication, and more of a reliance on kind of social engineering aspects of these various exploits. So that's one difference. Another difference is obviously the amount values of the individual kind of transaction events are lower, but there are many, many more of them. The attacks on the retail end of the spectrum are also more pernicious for several other reasons. One of which is that bad actors to kind of operate in that domain, they target the most vulnerable individuals that are out there, the most vulnerable individuals that partake in the financial system. Well, those are their targets, and for that reason, successfully executed attacks on that end of the spectrum are devastating to individuals. They're absolutely terrible. So although the amount values are lower, and you don't have these kind of big ticket items to go talk about. It's far more pernicious, in my opinion, just because of the impact that it has on individuals. So a lot of different. We see things on both ends of that spectrum, and of course everything in between. So no shortage of variety kind of out there.
That's interesting. So the one area that I wanted to actually explore with you, and it kind of speaks to your background as well, right? You actually were like, you started as a developer, then using math, and then you evolved into actually realizing that, and you know it better than most people, which is like data science and machine learning is one part of a broader problem-solving domain. Even the framing of how you actually talked about these problems are, less about the ML model that's going to do the anomaly detection better, or identify a pattern better, but it's more about how do you really solve the problem. And that involves you thinking beyond just the machine learning model to the data, the operational infrastructure, the ops engine, how you interact with different subsystems and ecosystems, if you will. Can you explore a little bit about, how that maturity that you guys developed at Q2, and, um, just explore that topic for me?
Sure. So the way that we inherited this, for instance, this fraud problem was in such a manner that we kind of had two problems that we had to absolutely solve concurrently. And one was a mathematics problem, and that had to
Mhm.
do with data and ML and building models and all of that kind of thing. And the other was an engineering problem because we had to do all of that all those mathematics, and we had to go through all those machinations and so on and so forth. But we had to do so from within the context of an absolutely critical production system. Um, so we had all kinds of conditions around, response time, and of course, all the common, the common things like false positive rate, sensitivity, specificity, and all that stuff. But from day one, we absolutely had to solve that engineering problem due to the criticality of the issue that we were addressing, kind of financial fraud, in oftentimes real time systems. So
Mm.
that that presented just a really kind of a complex blend of issues that are very different from one another. Training ML algorithms, doing mathematics, and building classifiers and using those classifiers on data, even large amounts of data, is kind of one thing. But then
Mm.
engineering into production systems
Totally.
is a very very different very different thing. It requires a different it requires a different set of discipline. You have to think about problems differently. The knobs that you can kind of turn are all just vastly different. But we had to solve each one of those kind of problems concurrently. Otherwise, well, like what good is you know,
Yeah.
what was I going to go tell Adam if I was able to train? Hey, look, here's what I've done. I've trained this great classifier. It can totally catch
Your F and score is so
all the fraud.
high.
Yeah. And here it is right here on my laptop. See? Great, isn't it? Well, obviously that was not going to get the job done. You need to take those classifiers and you need to get them out there as close to your end users as they can possibly be so that again, we can go solve their problems, which is all they really care about. So grappling with and this was this was 14, 12 years ago or so
Yep.
that we were first grappling with these issues, and as different and as challenging as each one of those issues was back then, they're still different and they're still challenging
Yep.
today, just
I was
in just
still struggling with
totally
that,
different.
that exact same problem. I mean, if you really think about, artificial intelligence, AI systems in general, or any kind of automated decision making systems, people are still struggling with the engineering problem than the science problem, right? It's not so much about the model anymore. It's like a much more broader ecosystem, all the different, touch points that you have to think about, and the end product, right? Which is like, how is it going to change the experience for my end user, right? What kind of benefit and so forth. One thing, and still, we see a crop. I mean, in fact, I would say you guys being in fintech, you're probably much ahead of the spectrum than some of the other industries. But everybody's still struggling with some form of the same problem. How do I engineer and productize machine learning? I mean, that's a huge challenge in general, right? And there's a lot of moving parts, and things are constantly evolving, from data models, and models degrade over time, data drifts over time, the whole nine yards. So one thing is like, what kind of makeup of you mentioned you got to build a different muscle, you got to build a discipline. What is the makeup of the SWAT team that can make this happen for enterprises, right? I mean, who do we need to actually be in that team to deploy a ML model into production and change history, if you will?
Sure, sure, great. It's yeah, you need people who are naturally and inextricably bound to to customer problems.
Mm,
They need to love the people need to love those problems, right?
yeah,
And if you do that, if you find people who are that way, they can't rest. Their job is not done. They can rest. We all rest. Plenty of rest.
yeah,
But their job is not done until the problem is solved. And turns out when you work with people like that and you build a team of people who are like that, you it never works to just say, hey, look, we built a model, toss it over the fence to the ops team or what have you, and then we're done. Call it a day. That never happens
yeah,
because it's not good enough. It's not good enough for the team. The
yeah,
members, comprise that team. So finding those kind of people, and oftentimes, you look for generalists are
mm,
totally fine, right?
yeah,
Because
yeah,
machine learning is so vast. It's such a vast discipline. There's no person who holds all of that in their head. Well, what can you do? You begin with the problem, you back into the technology, you back into the data. You will become an expert on whatever it is that you need to become an expert on. If
absolutely.
that has to do with, with an algorithm or a specific piece of optimization, fine. If that has to do with something on the on the on the SDLC side or on the kind of deployment pipeline end, well, same thing. We have to go get that stuff done. So none of these problems take precedent
Yeah,
over any other. They're all important. So again, you just have to you have to you have to find the right individuals, and you have to give them the kind of the autonomy, and then and then kind of the responsibility and accountability come part and parcel with that. But if you align those things appropriately, then I think that you've got kind of
yeah.
a winning recipe there.
No, it's interesting. Something that you said is actually very, very profound, right? Which is, if you really think about the space that you're trying, the class of problems you're going to solve with machine learning, by definition, these are probabilistic solutions, right? I mean, because you're trying to predict something, you're trying to, gain confidence in something, you're looking for insights, that meet a certain criteria, but it's always probabilistic. So by definition, these are experimental in nature. You got to try different things. You got to learn it. You got to have that feedback loop going and stuff. So that makeup of the individuals, like you said, you want generalists who are just, mission bound on trying to solve that customer problem, and then being able to, not be rest until they get to the answer, and then learn from it. Oh shit! I mean, I didn't. That's not what we expected. So we got different feedback. Let's redo it, right? I think it's so profound what you just said. That right. Um, what we also realizing, what we're hearing from across the industry is also, is like, your design is a very important aspect of this thing. So if you user design, user experience design, because giving like training models and giving inferencing in a Jupyter notebook is a totally different ball game than how do you build that trust with the user when you actually give a recommendation. Like, I back 5-6 years ago, I worked pretty extensively with early adopters in the financial services industry, and one of the big problems we were solving was wealth managers, right? So we were going to give the ability to get a rich profile of a wealth client, a high net worth individual across all their digital and non-digital footprints from all over the place, all different data sources, to really personalize and tailor, just give them like Jarvis suits to go and serve those clients better, right? And what we learned was, it was not so much the data that allows them. That's just by knowing that the wealth manager knows a little bit more about that patient, the his wealth clients, his actual high net worth individual's daughter going to college, so I can sell a new product to them. more than that, what really mattered was the relationships. It was like, I need to remember the daughter's name. That was more important for me because I'm managing a high touch client here, right? So we learned very quickly that it's not so much jumbling up a whole bunch of information. It's like contextualize it, make it real, make it really, and then build that trust in them because they don't try, like, dude, I have a really high net worth client that is paying my bills, my family's bills for like decades now. I'm not going to screw that up by taking some stupid recommendation from a machine learning model, right? So you got to think through the trust you have to build with them, and design becomes such a strong element of building AI systems or machine learning systems. Right? So yeah, we see that we're seeing that over and over again, and I think everybody's waking up to it. Right, the whole notion that okay, you got to put design front and center on how we solve this problem.
100%. I mean, explainability is uh, is is so important. Part of it is, like you said, it's a hearts and minds thing. You know, when you talk to experts who have been doing things a certain way for decades, um, and hey man, if you've got something better, well, you need to convince them that you have something better. And part of that is just a frank assessment of the data,
Yep.
but that's not all of it. There's this hearts and minds aspect of it as well. And even before you get to any of that, um, there's a component of just as a practitioner,
Mm-hmm.
coming into a problem. What do you what do you not know? And me, preferably, the answer to that is almost everything. Like, those are the good problems, right? You go into a good problem, and there's kind of not a lot to go on. You have to learn. That's where I prefer to. That's where I really like to work, and I find that that's a place that a lot of value comes from
Understand.
as
Yeah.
well.
No, it's interesting. So you use the word explainable, explainability, and explainable AI. I mean, shifting gears to that topic, right? This whole notion of being able to do AI responsibly, ethically, with the right security measures and privacy features in play. Now you're at a, you hold a lot of customer data, and you have a very, diverse team of different kind of skill sets, different access rights, and so forth. It becomes important that in machine learning, since you earlier said it's often a team sport, right? You got to have multiple people work on the data. You have data scientists, the designers, and stuff like that. Sharing core data becomes a challenge in itself, right? Because you have everybody need to have access to the person, the what they need to have access to do their job, but also you want to minimize the risk that you're going to do by exposing customer data everywhere, right? So what are some of the interesting innovations that you see in that space of, like, how do you do machine learning in a lot more responsible manner? I mean, there's a ton of tools out there, there's a ton of frameworks out there, right? But talk about some of the exciting things that you're seeing in that space.
Sure. So I think that it begins with understanding your customer in a very deep way, and that happens with time, curiosity,
Yes.
caring about that. And like, if you do that right, well, first of all, there's an opportunity to learn a whole lot about the customer that you're serving. But there's something else that kind of comes up as a side effect of that, and it's a critical side effect, and it's that um, you learn how to define the interface between the customer and the machine learning apparatus that you're building that's going to eventually solve their problem.
Hmm.
So by spending all that time with your customer, by learning all the things that you don't know that they do, and then going back and building something that they couldn't build, but
Hmm.
that you can because you spent so much time with them and other people just like them. Well, it turns out, over the course of having those conversations over and over again, listening and being curious, you get to um, you get direct line of sight into what that interface would look like. Again, the interface between your customer and the machine learning kind of apparatus that's going to solve their problem. And that interface it's critical that you define that interface in terms of a language that your customer will understand.
Mm.
And you only get to kind of suss out what that language consists of, and how it flows, and what that language can represent. You only get to know about that by spending time with your customer. and
Yep.
by going back and just beating your head against the problem that you're trying to solve for them. But the API, or the kind of the interface, it's not, I guess it's not an API in the traditional sense, but um, learning about the components, kind of the verbs,
Mhm.
the objects that are going to comprise that interface, is a very, very critical task, and it's something that application developers do a lot, but machine learning engineers, they don't. And you don't really see them doing that a bunch, because it's not a traditional interface, it's not a traditional API. Nonetheless, defining that API is critical, and I find that, like, the best way to define that interface is in terms that your customer will understand, in terms of their specific and expressed business problems.
Mm.
That's the interface. That's the interface between your customer and your ML apparatus, however sprawling and complex that apparatus might be. It needs to have a very clean, succinct, and well-defined, understandable interface upon which to pass value back to your customer.
Mm.
So that's to me, that's where all of this begins. Explainable AI, um, delivering a product that solves an important problem for a customer in a natural way that doesn't require the customer to go, you know, do a bunch of extra work. It all begins there, and
That's the core.
that's kind of the nexus of everything else that happens interesting downstream from that point.
There's like, this whole space of responsible AI. It's not like one giant thing, like you said, right? There's so many different aspects of it, right? One issue is privacy. Like, that's where I was really going with that question, was also, look, so much about the customer and you're collecting so much data, your data assets are so rich, but how do you empower? Maybe there's a third party team that has to work on this data, but you can't share uh, the personal data of the patient, of the I keep thinking in patients because I'm building a healthcare company in AI, right? So, of a customer. On the other hand, you also know too much about that particular customer set, that you're now coding in implicit and explicit bias into your machine learning and how you think about the problems, right? So, and then you have in a case like yours, you have to worry about adversarial attacks, the whole nine yards, right? But just that two space where, like, with privacy being, when you're doing direct to consumer kind of solution, even though you're a B2B business model, you're actually dealing with consumer data, right? And then on the other hand, how do you make sure that you keep it away from uh, your really smart people not to code in their bias and what they see in the data? How do you solve that problem? What are some of the um, methods and innovations that I know you guys have been. We talked about it briefly before the call too. So explore that a little bit for me. Yeah.
Sure. So I'll give you a good example. One of the particularly pieces of sensitive kind of information that we pass around just as a matter of course, because we have to, in order to solve problems, is consists of check images, digital check images, typically that are inbound to systems via
Yep.
what are referred to as mobile remote deposit capture components. You get a paper check, take out your phone,
Yep.
snap a picture of it, and deposit it into your account, going about your way. Turns out that that general landscape is pretty rife for a wide swath of different kinds of fraud.
Got it.
No surprise there. But again, in order to address some of the kind of fundamental concerns there, well, what do we need to do? We need to operate on the pixel components of those images in a very deep way, via a set of computer vision algorithms that we build, maintain, and deploy. Um, so we have this. What do we do? We've got this really sensitive data that we need to pass around into our systems in a material way. But we would prefer not to pass around a bunch of sensitive data if we don't have to. So we partnered with a company here in town called Protopia AI on some really, really interesting techniques that we can use on that front. What Protopia does, they offer this product. It's called stained glass, and what we do is we have a process that we embed into our systems at train time.
Hmm.
What that process does is it will, as we go through the kind of the training, test, cross validation process, these large CV models, that process that we've embedded into that general kind of pipeline system, it produces an artifact. It's there all the while, but it produces an artifact at the end of our kind of training process. What that artifact does is it allows us to ship that artifact um, to the extremities of our
Yeah,
system, to the
interesting.
clients on our
Yeah,
system, the ones that are passing us in, these check images. And what that artifact will do from Protopia is it's called stained glass. It will obfuscate the pixel components of the image itself in such a manner that post obfuscation, the image is it's irrecoverable. What you see is it appears to be noise to
hmm.
any to any user, expert or non-expert. You cannot tell it's a check. It's just it's an image of what appears to be noise spread across a grid of pixels. But there's not enough noise in that obfuscated image that we can't pass that very same obfuscated image into our downstream
Machine learning.
CV classification algorithms, and we could still get back. We could still maintain
Yeah,
the numbers that we need to maintain in terms of sensitivity, specificity, even post obfuscation. So now we get kind of the best of both worlds, right?
interesting.
Here in our kind of inference processes,
Yeah.
we can still maintain the same efficacy or similar efficacies that we would have without any obfuscation at all.
Hmm.
Um, so that's nice because our algorithms are still effective and they're still
Yeah.
good and they're still doing the things that we wanted them to do in the first place. And simultaneously, we don't even get to see the actual data as it traverses over our or the unobfuscated data as it traverses through our system. So a really compelling and surprising and interesting use of technology there on the data privacy
And it is
side.
actually, it is not necessarily a form of encryption that you're doing. It's basically you still maintain the fidelity of the data for the machine readable formats for the algorithm, but you introduce noise actively into a way that it doesn't become human readable, right? I mean, and I'm assuming there's some proprietary algorithm that protects another someone else to go in and apply a reversal of that algorithm to extract the actual ground truth from it, right? So they can't do that either. That's fascinating because it kind of solves a lot of the. I mean, we live in a world where more and more of the inferencing is moving to the edge, and the like I think it was Peter Levine, somebody who about 5 6 years ago talked about this whole notion of how the cloud will become the university for machine learning models, where it'll go to train, learn, and things like that. But almost all the inferencing is going to be pushed into the little tiny chips that's sitting on your sensor at the IoT device at the edge, right? And this is a great way to make sure that when that happens, in that transition, we're seeing it. In your case, it's still in the cloud, but in your customer deployment environment versus your own centralized cloud where you train the models, you're able to maintain the fidelity of the efficacy of the process without compromising data security at the edge. So I think that's the big use case that you see. It's pretty fascinating. I'll look them up. I'll actually look up Protopia, and I just checked them, protopia.ai. That's awesome. No, Jesse, this is great. One shift. I mean, we covered a lot of ground. Everything from talking about the fraud-based problems that you solve to going into the need for looking at it from how do you engineer a solution rather than just build machine learning models, to going specifically into responsible AI, and love the specific example of that very particular use case. Because I tell you, there's a lot of conversations I have about this and responsible AI. People give there's a lot of stories around, oh yeah, there's bias introduced, so we got to do this, right? But what you gave was a very practical, very unique example, which is a real problem everybody's going to face if they're already not facing, that they have to go solve for. I want to. My last question to you is for other folks watching you who want to build a career in AI or machine learning or be a data scientist and stuff, right? What's your advice for those young and up and coming data scientists as a whole? There's a lot of university students and grad students and postdoc researchers who view this particular podcast. So give us what's your top three advice to all of them if they want to build a career in data science?
Yeah. Okay. Great. Um, so I would say, yeah, don't lock yourself. Don't lock yourself in a classroom with a chalkboard and a calculator, because the classifier itself, even the most perfectly trained and pristine classifier that is wonderful in all ways, like it doesn't mean anything unless you put it in the hands of someone who has a problem that thing can solve. So approach it with the kind of the mind of a generalist, right? Sure, you need to do some mathematics, and you're definitely going to need to learn a whole bunch of statistics. That's what I had to do, and that's what I still do. So that part is, that's obviously a critical component. Build from first principles, understand what you're, understand the foundational ideas that what you're doing is built upon. So sure, do that, but don't rest. Don't rest until you've also solved the equally compelling problem and equally important problem of of engineering a system that's efficient with respect to its ability to take that model you just trained and deliver it to a person out there in the kind of in the world. As you do that, I would say keep an eye towards simplicity. Occam's razor.
Yep.
Um,
Occam's razor.
it's our jobs are hard enough. Our jobs are hard enough as it is. We certainly don't need to introduce any additional complexity, especially if we don't have to. Look for simple systems. Look for, you talk about explainability. I think so just as explainability is important in AI, mathematics, machine learning, data science, it's also important in engineering, just as important, critically important. So what does that mean? What does that mean? Explainability and what's the analog to explainability in AI? Explainability in engineering. I'll tell you what it is. It's infrastructure as code, IAC. There was a time not too long ago when I myself had to work with systems that were they're sprawling, complex, very, very difficult and unwieldy to kind of pick up and move around. And there are many reasons for that. Where the problems that we engineer for are difficult. They require oftentimes large scale systems. And like I said, there was a time not too long ago where that became a problem for us, became a problem for our teams. And nonetheless, we were using tools to administer those systems. It was a distributed system. So we're using Puppet, Ansible, so on, so Salt Stack, so on and so forth. Collection of technologies there that were all kind of centered around container orchestration, just managing these distributed environments in as sane a manner as possible, but it was still very, very hard. So you fast forward to today, and you kind of look at some of these amazing things that we're able to do with cloud computing, kind of infrastructure as code overlaid on top of that, and you go in and you're able to declaratively describe the entirety of your system, the entirety of your distributed and complex system. But if you're able to use a declarative system like CloudFormation, Terraform, CDK to do that, well, now it's just code. It's not, it's not an explainer video where you have somebody walking you through kind of a UI. You got to click on this and wait 5 minutes, and then once that's done, you got to go check these 12 things. And if 6 of them look like this, and the other ones look like that, click this other thing, that kind of thing. Never, ever do that. We don't want to do that. So we replace all of that with just code, just declarative code. For me, that's the engineering counterparts, the engineering analog to explainability in AI, and it's absolutely critical. So go learn those things too, because that's a very, very important. Just as statistics and mathematics are an important piece of your toolkit, learn how to build systems, learn how to think about systems.
Level thinking system.
Yeah, very, very, very important.
Awesome, Jesse. This has been fascinating. Very, very, very informative conversation. Where can the viewers and listeners get in touch with you? Where can they find you on the internet?
Oh boy, I was not prepared for that one, Ganesh. I'm like, okay, let's see. Where can they find me? What do people usually say during these parts?
LinkedIn, Twitter. You're on LinkedIn, and
That's the only one, man. I'm not a. don't have a large presence out there.
Yeah, but I think like, well, you can call out if someone reaches out to you just to follow your journey there and make sure that if you're adding any thought
Got it.
leadership or anything like that.
Yeah. So I'll just do. I'll say. Just give me a sec. I'll just say LinkedIn. I'll give them my Q2 address. Does that sound good?
Perfect. That sounds
Okay.
great.
Yeah. You want to ask the question again, or should I just go into it?
Good. Just go into it.
Okay, yeah, great. So I'm out there on LinkedIn, same as the rest of the planet, and you can find me at Q2 at Jesse Jesse Barbour Barbour at Q2.com. Reach out to me. I'm happy to chat. I love talking about these problems. So really do mean that. If there's something you're curious about, something you'd like to pursue further in terms of discussion, reach out. Let's talk.
Sounds good. Thank you, Jesse. Thanks so much for taking the time today. Yeah, that was a blast.
Absolutely, Ganesh. Thank you so much for having me. Really enjoyed the conversation.
Appreciate it.